Good evening, students. Good evening. Good evening, everyone. Good evening. Am I audible? Very good evening, Manish. Very good evening, Sujata, Durga Prasad. Good evening. Good evening. I hope that you people are having your snacks and by this time your snacks are finished. Yeah. Good evening, Swendra. Good evening. Yeah, it's decent level as per NEET level. It is. Yeah. Good evening. Very good evening. So, how are people? How's going on? How studies going on at home? The point is, you have opted for the online mode, How studies are going on? Good evening, Suharsita. Good, okay. It will be informed. It will be updated. Okay. That exam who is conducting finally when updation finally notifications when it will come, then only we can say. है ना? But it won't matter whatever they are going to conduct. Ultimately, it is target is that they are not going from the NCRT beyond NCRT. So you have to prepare as per that. Whoever will conduct. So don't worry. Only thing is be regular. Try your best in the PACE exam. If you are working good in the PACE exam, then what will happen in the SPACE exam? Your preparation is up to the mark. You don't have to fight much, and that is repeated again and again. That is repeated again and again. Yeah, good evening, Naveed. Yeah, this will be given in the groups. Exam will be on Monday. It will be informed in the groups. It will be informed. ठीक है. I hope everyone is fine. They are preparing well, and the momentum which is required with time. I hope that you won't lose that momentum, because at home sometime it happens that your preparation you are not going to know that how it is going on, because you are not in the competition with the students. Yes, so Harsita, it is a group is there, WhatsApp group where Prasad ji is there. He's taking care of the all messages. So already I think you are here, so you can you might be added in the group. Not on Sunday. Naveed, test is not on Sunday. Sunday class is there. Then on Monday and Tuesday. Okay. ठीक है. So start करें. Shall I start? Last part was some examples given. Some examples given about the structures. You have to find out the geometry and everything. I hope that you have done. Almost 30 examples are there. I think 30 examples or 31 examples are there. So completed those examples. Completed those examples. 31 examples here. Vijay, yes, 31 examples maybe. So among these examples, anyone you want to ask? One example, SOF4, okay? SOF4. Any other example? Acha, one example is there, I think, which is XCF6. XCF6, or you can mention in your notes AB6L type structure. AB7 we have done. In AB7, if one bond pair is substituted with one lone pair, so it becomes AB6L. Then you will be able to solve which example? XCF6. It is given or not? XCF6. Check. XEF6. XE F6 example. This is distorted octahedral. It is which one? Distorted octahedral structure. XCF6 belongs to AB6L type distorted octahedral, or it is also said as capped octahedral, but in which here is the lone pair and this is the other bond pairs. Okay, so you can add in your notes. XCF6 example is basically 6 bond pairs and 1 lone pair, AB6L type. Written AB6L type structure. Then you, in the last class examples, you can solve which example? XCF6. Okay, now remaining example, one of you asking, Sesri asking the N3 minus, okay. PCL6 minus AB6, it is directly ALF6 3 minus, it is also AB6 type. ALF, only charges will be there because aluminium is there, na, d orbitals are used. ठीक है, start करें. Return this part, AB6L type. अरे भाई, return, that is written AB6L type. Then I will discuss SOF4. Okay, SOF4 में sulfur, how many valence electrons? 6. With oxygen, double bond. ठीक है, and with fluorine, 4 single bonds. That means sulfur has used all the 6 valence electrons. So you will understand that it is AB5 type structure. How? You can observe 1 oxygen, 4 fluorine, 5 atoms, A, B5 type, trigonal bipyramidal, sp3 dehybridized. And double bond occupy which position? More spacious position, which is equatorial position. Okay? Then which example? N3 minus, you write the structure. N3 minus is a linear structure like this. And this is which hybridized nitrogen? sp hybridized nitrogen. So some example, so that structure we know, like N3 minus, it is derived from hydrozoic acid, or ALF6 3 minus, if you observe, it is AB6 type only, octahedral, sp3d2 hybridized. Yeah, good evening Kaushik. Copy it, AB6 type, ALF6 3 minus. ठीक है, PCl6 minus same, AB6, central atom phosphorus 6Cl, net charge -1 on phosphorus. So you will mention net charge -1. Any other example? Any other example, or I will change the slide now. ठीक है, I am changing the slide and I'll discuss some examples. I'll discuss some examples related to, yeah, PCl6 minus sp3d2 hybridized phosphorus, and I'll discuss some bond parameter questions. Clear? So apply VSCPR and hybridization in those questions. It is, you can write the heading, it is bond parameters. When you read in NCERT, you will read the definitions, like which one? You will read bond angle meaning, bond length, bond enthalpy. Okay, definitions you all know, but still you read the that definition part. Okay, NO2 plus, very important example. NO2 plus is what? NO2 plus is linear structure, N double bond O plus charge. N is which hybridized? sp, important example. sp hybridized linear structure, bond angle 180. ठीक, now bond parameters में apply your learning portion, which is hybridization as well as VSCPR together in bond parameters, including somewhere VBT also required. I'll tell where. So firstly find out or compare the bond angles among them. compare here. In bracket I am writing which parameter to be compared. Keep on writing the answer together and write the examples with more spaces in between so that you can add the explanation in between. Do not write totally cut to cut example. Here you can space, you can mention in the notes, then you can write the another example. And when I explain, you add the points. First one is CH4, CH3 written galti se. Bond angle comparison, BA is written. Keep on comparing them. I will give the answer and I will give the explanation. Firstly, you try at your end. Bond angle comparison. ठीक है. You can write decreasing order, increasing, whichever you are getting. Decreasing, increasing. I'll mention here. CH4, BF3 and BCl2. If you observe, they all belong to different type. Yes, or they belong to different hybridization. CH4 is which type? AB4 type. BF3 which type? AB3 type. BCl2 AB2. AB2 means linear. Yes, bond angle 180 degree. BF3 trigonal planar, bond angle 120. And CH4 AB4 type, it is 109.5. So you can write any of the way, both will give you correct answer. SP3, SP2, SP. Hence bond angle will be this one. Getting it? Yes, keep on checking your answer also. And if you want explanation, you can write there as well. Their type and hybridization together. Done first example. Similarly, try next two. Bond angle comparison. ठीक है, second example में, if you see, all are which hybridized? All are sp3 hybridized. So if you go by hybridization, you cannot get the answer. So we will use VSEPR model. ठीक है? CH4 AB4 type. Hybridization is sp3. NH3 AB3L type. Hybridization is sp3. H2O AB2 L2 type. Hybridization is again sp3. Now AB4 lone pair is introduced, AB3L, further lone pair introduced, AB2L2. As lone pair repulsion increases, bond angle decreases. So here answer will be maximum pairs AB4 regular geometry, then one lone pair slight distortion, then another two lone pairs. ठीक है? तो as lone pair on the central atom increases, bond angle decreases. And geometry is same for all. Electronic geometry is tetrahedral. Clear? So what is fixed here? Here electronic geometry is same. Difference is number of lone pair increasing on central atom. So bond angle becomes directly proportional to the, bond angle is inversely proportional to the lone pair on central atom, considering electronic geometry same. One thing. Second is, already you have learned the bond angle for CH4, 109.5. Ammonia, what is the bond angle? Ammonia, 107 degree. Water, 104.5. So these are the angles we know already. So whichever we know, firstly we use the information. Okay? Logically also can be explained, lone pair increases on central atom, bond angle decreases. Okay? Getting it? Now try next example. NH3, NH4 plus, same concept. NH4 plus, it is also sp3 ab4. Ammonia also sp3, but it is ab3l type. Now tell, as lone pair increases on central atom, bond angle decreases. Therefore, this is second greater than first one. Yes, very good, very good. Yes, Suharsita, Dagula, Kavita, Durga, correct it is. Yes, 2 greater than 1. Similarly, try for next 3. 4, 5, 6, I'll discuss them together. ठीक है, 4, 5, 6 done. At your end you can try, whether right or wrong that we will discuss. At your end you have tried it, it's good. Firstly, I will use the information we have learned. SO3 AB3 type sp2 hybridized sulfur 120 undoubtedly. SO2 we have learned from NCERT, it is distorted, bond angle is 119.5. So I firstly prefer that we remember the information. Then logically also it is easy to explain, it is 119.5, already we have done, it is 120. One thing. Second thing is what you can mention, AB3. SO2 is AB2L type. AB2L derived from AB3 only. So as lone pair increases, bond angle decreases. Lone pair on central atom. आई बात समझ में? Reasoning you have to keep on writing as per you understanding it, fine, but keep on writing some explanation so that you will not forget it. ठीक है? Done? Now try next example also. अरे भाई आ रहा है समझ में? कोई डाउट? Up to 4th example. Any doubts you have? Any doubts up to 4th? ठीक है. Here in 4th order will be SO3, AB3, AB2L type, or hybridization will not give you answer. In 5th, which is better? In 5th, 1 greater than 2. Correct, Durga Prasad. 5th, 1 greater than 2. Sajid already said. Very good. 5th is 1, 2. Yes, Swarsita, correct it is. Reason, it is AB3 type. It is AB3L type structure. Or you can say it is sp2, 120. It is sp3 hybridized AB3L. That is why bond angle will be 1 greater than 2. Yes, correct. It is Kavita, correct. Vagdevi, correct, it is very good. Keep on doing it, keep on doing the answers. I'll explain and you try as per your understanding of VACPR and hybridization. ठीक है, चेक करो. In question number 6, NO2 plus, already I said important example, AB2 type sp hybridized, hence it is 180 degree. NO3 minus sp2, NO2 minus structure sp2, both are sp2. Now NO3 minus is AB3 type, NO2 minus is AB2L type. So between them, as lone pair on central atom increased, in NO2 minus bond angle decreased. This is around 120 here, this is around 115. No need to remember the angle, just I am writing. Logically you have to write SP 180 or AB2 type. It is AB3, SP2, NO2 minus SP2, but it is AB2L type structure. Getting the reason? Now in 7th and 8th, observe they are of same type. S, it is AB3L type, AB3L type. ठीक है, AB3L, AB3L type. What is same? Attached atom same. What is same? Lone pairs are same. Only difference is central atom. So if geometry same, lone pair same, and attached atom same, central atom is different. More is the electronegativity of central atom. What is the case? More is the electronegativity of central atom. More will be the bond pair repulsion. More will be the angle. More will be the bond angle. So among them, which is most electronegative? First one, nitrogen, then phosphorus, then arsenic. So here the bond angle is more for ammonia, then arsenic, then you can say SbH3 also there. And here bond angle, you all know it is 107. But important information is these bond angles are closer to which degree? 90 degree. Why am I mentioning this information? Already order is there. Bond angle is directly proportional to electronegativity of central atom, considering geometry and attached atom same. Now here point is, in the case of ammonia, bond angle observed it how much? 107. If it is 107, then we can surely say that hybridization has taken place in nitrogen. That is why 107 is closer to 109.5. है ना? Tetrahedral angle we know 109.5. Due to lone pair bond pair repulsion, ammonia bond angle is distorted. So 107 is explained by which concept? Hybridization. ठीक है? You cannot explain by normal atomic orbital overlap. Getting it? You cannot explain it by which way? Normal atomic orbital overlap. Why? Because when normal atomic orbitals overlap takes place, px orbital will be involved, py involved, pz involved. Yes or no? And these atomic orbitals are exactly perpendicular to each other. These atomic orbitals are perpendicular to each other. So if atomic orbitals are overlapping of nitrogen, then angle will be closer to 90 degree. It should not be closer to 109.5. So that is how we can interpret it, that in ammonia, nitrogen 107 can be explained by which factor? That hybridization must be taking place. Now think about after the down the group, PH3, ASH3 and then SbH3, their bond angles are not closer to tetrahedral angle, rather they are closer to perpendicular 90 degree. It means what happened down the group, that means after nitrogen, or that is after second period onwards, third period, fourth period, fifth period, these atoms, central atoms, are not undergoing hybridization with hydrogen. They are using their which orbitals? Pure orbitals. That is why bond angle, is closer to which one? 90 degree. Getting the point? So here point is only important is the bond angle observed is 90 degree, and down the group after nitrogen the elements are not undergoing hybridization with 1s orbital of hydrogen. They are using their pure orbitals. How it is confirmed? By the observed bond angle values. Clear this story? This case is similar with which one? Water. That in water the bond angle is closer to tetrahedral angle or not? 104.5. You can easily explain it by hybridization. Yes, but down the group after oxygen, sulfur onwards, central atoms are not involved in their hybridization with hydrogen. And that is how order, so you can write the same like this. And here it is approximately 90 degree, and you will say here also no hybridization taking place. Clear this story? That it is termed as Drago's rule, but yes, correct it is, but this term is nowhere given in NCERT. So even if you know the term, the point is that how it is confirmed, we confirm it by the observed bond angle values. The explanation is given then. That with second period it is observed, and with third period onwards with hydrogen, these elements are using their pure atomic orbitals. The energy gap is high, 1s and 3, third period and fourth period onwards. Okay. Now in 7th, 8th, 9th is normal example. In 9th, if you observe, geometry is same. 2 lone pairs on every oxygen. Central atom is same, attached atoms are different. What is different here? Fluorine, chlorine, bromine and iodine, you can say possible, we can write. So among them, how to compare bond angle? Bond angle will be maximum where the size of the atom, bulky atom is more. It is one way. That among them, geometry same, central atom same, but attached atoms are different. So bulky groups are there. It is one such way that their repulsion factor dominates, and here it is more, lesser will be OCl2 and least will be OF2. So you will understand logically also. By which way it is? By the bulky nature, or other way is also said like bond angle inversely proportional to electronegativity of attached atom, but there are variations in that. There are variations, so generally you understand by bulky nature of the halogen atom attached. But in this case, what is observed? Oxygen same, both are central atoms same. Difference is only attached atom difference. It is hydrogen, it is fluorine. Here observation is, this is more as compared to OF2. How much it is around? It is 103. It is 104.5. Exact value, if it is there, I will tell. For OF2 is 103 around, yes. So here how it can be explained? It can be explained that higher electronegativity of fluorine, where OF2, these bond pairs are more shifted towards the surrounding atom. That means towards fluorine. Getting it? If attached atom is more electronegative, what will happen? The bond pair electrons are away from the central atom. Yes, but if central atom is more electronegative, the bond pairs are more closer to central atom, more bond pair repulsion. More bond pair repulsion. Getting it? So this example which I have marked it is not given by size of the attached atom. It is given by the more electronegativity of fluorine. That will be explaining that due to the more electronegativity of the attached atom, the bond pairs are more closer to the fluorine, hence less bond pair repulsions as compared to H2O. And this is confirmed by which way? The bond angles. ठीक है, then other examples we can do. ठीक है, up to this part. Now in 11th example, normal way we will use which one? Cl, bulky nature. Cl which nature? Bulky. Attached atom different, central atom same, lone pair same. Answer is this one. It is around 111 degree. It is around 104.5. So normal case, but in OH2 and OF2, there the exception. Exception you can say, or difference of bond angle arises because of electronegativity higher of chlorine, of fluorine. ठीक है, now see, in 12th, CO2 which type? AB2, hybridization sp. CO3 2 minus AB3 type, hybridization sp2, 180 degree here, 120. Now in 13th, try this example, but remember here what is written? Bond length and bond energy. 13th is about which comparison? Bond length. In VBT we have done. Remember, in 13th, the bond length will be where maximum? HI. 13th, yes, correct, it is 431, yes, 13th correct. Can you tell the reason for that? Why it is maximum bond length for HI? Anyone? Why the bond length is for HI? Very good. The size of the orbitals used by the atom is increasing. HF means 1s of hydrogen and 2p of fluorine. Take HCl means 1s of hydrogen, 3p of chlorine, then 4p, then iodine 5p. 5p means maximum distance from the nucleus. Maximum distance means maximum bond length for HI, and generally if you remember, bond length and bond energy are inversely proportional to each other. Therefore, here exactly opposite. Apply the concept exception if you remember here, write down that one. ठीक है, अब देखो इस वाले एग्जाम्पल में ऑलरेडी you all remember I2 maximum y in I2 which orbitals are overlapping 5p 5p. ठीक है, 14th का करेक्ट आंसर बॉन्ड लेंथ आ गया. एंड if you remember bond energy we have done that in case of halogens bond energy is difference. Yes, exception is there because of which reason you have written, because of, yes, very good, tell what's the reason why this is the order you have written earlier also. What happens that F2 becomes lesser as compared to Cl2 and Br2, which factor you have written? That might be a reason. Yes, the reason is fluorine is small atom, each fluorine has 3 lone pairs, small atom 3 lone pairs, more repulsions. So you have written the reason LP repulsions in fluorine. That is the reason which explains this bond energy order. Yes or no? Clear? Now, in next case, bond length. You can easily identify 15th. Triple bond between carbon कितने bond? 3. Between carbon 2. Between carbon 1 bond. Where bond order you can say maximum here. Bond order is directly proportional to bond length. What is bond order? Simple meaning number of bond between the two atoms. So more is the bond order, lesser will be the bond length. Maximum bond order, least bond length. Getting it? आई बात समझ में? That here between two carbons 3 bond, strongest bond, shortest bond. That is another way to understand. Or bond order maximum, least will be the bond length, stronger will be the bond. So you can mention here bond order is inversely proportional to bond length, directly proportional to bond energy. ठीक है, next example, CO structure is how many bonds between carbon oxygen? 3. One dative bond, other normal bond. CO2, all remember it is linear structure, double bond exactly present. And CO3 2 minus structure is carbonate ion. Clear? Now among them, CO bond order 3, CO2 both sides C double bond or bond order is 2. But in case of CO3 2 minus, you can understand CO bond order here only one is double bond, remaining 2 are single bond oxygen. So bond order can never be equal to 2, it is always less than 2. Where CO3 2 minus, hence bond order inversely proportional to bond length. Maximum CO bond length here, minimum is there. Why? Because here 3 bonds exactly present, bond order maximum. Here 2 bonds exactly present, left side CO also double bond, right side also same. But here CO 3 bonds are there, out of 3 only one double bond, remaining single bond. That is why it can never be equal to 2, it is always bond order less than 2, partial double bond character. बोलो भाई, आ रहा है समझ में? But after the class you have to try these examples again. You can write randomly, you can try these examples. ठीक है, try 17. Let us see how many of you getting the correct answer. 17th. 17th May, one answer came. So Harshita said it is fourth. Fourth means F2 bond. Remember, it is all bond energy comparison between single bond. Carbon carbon single, NN single, OO single, FF single. All students try this one, 16th, 17th. Then we will try the. Then we'll start with the dative bond part. Meaning of dative bond. Okay, one answer coming is 4321, other is 4321. Very good. Manish Challa is saying 4321. Okay, any other answer or other student getting it? All the students try to find the answer for the last example in bond parameters. 4321. Naveed, okay. 1 2 3 4. Kaushik saying 1 2 3 4. Yeah, why Kaushik? Why 1 2 3 4? Bhai? Ananya saying 4321. Okay, Ananya, we'll see. Kaushik is saying that it is 1 2 3 4. Is it decreasing order or increasing order? Kaushik. Kanti saying 4 3 2 1. I am considering 4 3 2 1 means you are considering the decreasing order. Yes, Kaushik. Tell. 1 2 3 4. Sehasri is saying bond order relation. Bond order. Okay, we'll see. F more size. Oh, if you remember in periodic table chapter you are doing, Kaushik, along the period, atomic size, what happened? Kaushik, fast. With the speed of light, you have to respond. Along the period. Yeah, so Kaushik saying that fluorine have more size. 4 3 2 1. That student Sehasri, explain it more. If you your answer is 1 2 3 4 in decreasing order, I think it is. So what's the reason? Chandu is saying 4 3 2 1 decrease. Okay, you are saying decreasing. Okay, any other student who? How many of you considering it is 1 should be maximum? Chalo. How many of you considering CC bond strength 1 maximum, then 2, then 3, then 4, fourth is least? Tell me. How many of you in their mind this is the answer? And they are not able to type. Sehasri is saying reason, actually I want the reason explanation. You are saying bond order relation. Bond order is 1 only. All are same bond order. Any other student? Kaushik, you didn't give the reason. You are saying some other reason. Your answer is given same bond length. Bond length will be variable. Different atoms are there. Bond length we cannot say. We can say single carbon single bond length. Acha, Bhavya is saying. Acha, can you say the reason also? Those who are considering it should be 1 2 3 4 decreasing order. Can you give the reason? En difference won't be there. Why? Every atom is bonded to its same atom only. One answer is coming now. Kavita said, very good. Answer is 1 2 3 4 decreasing order. Reason is lone pair repulsions. Remember one thing, we are not comparing oxygen double bond with nitrogen triple bond. We are comparing all singly bonded atom. Carbon with carbon single, N with N single, O with O single. So as lone pair is increasing, repulsion factor, bond strength is less, single bond length. So final answer given by Kavita, very good. Catenation, no. Catenation is the resultant of these favorable factors. That why carbon forms so many bonds. Strong bonds also. Clear students, that is the part of the bond parameters which involves hybridization, VSEPR mainly for bond angle. Bond length can be compared by the BBT also or by resonance also. ठीक है, चलो next part. Next start करें. ठीक है, let's start next part, which is coordinate bond or dative bond. Only get the idea because dative bond is useful for certain examples, and these 6-7 examples they are rotating everywhere. So understand those examples, and then your life will be easy for that coordinate bond examples which we have done. So what is the meaning of coordinate or dative bond? What's the meaning of coordinate or dative bond? It is basically a type of covalent bond. Write down in the notes. It is a type of covalent bond. It's a type of covalent bond in which one atom donate in which one atom donate an electron pair known as donor whereas other atom accept the electron pair known as acceptor ठीक है general meaning clear that when it's a type of covalent bond out of the two atoms one is donor one is acceptor one donates complete electron pair other accepts the electron pair that's why donor is which term Lewis base acceptor becomes Lewis acid ठीक है it's also a type of covalent bond basically polar covalent bond you can say and how we represent it for example atom A is there and here atom B is present atom A contains lone pairs and atom B contains vacant orbital because which is accepting should have the vacant orbital available then only it can accept so here A and B if they combine or A donates the electrons to B so it is represented by this way that A has donated the electrons to B it's a coordinate bond other way of writing is you can write single bond normally and here A with plus B with minus it is also a representation but once the bond is formed now it is just like normal covalent bond once bond is formed it is normally but only way is that we are identifying here which is a donor and which is acceptor so we are mentioning a coordinate bond once it is formed it behaves like a normal polar covalent bond return now we will talk about which particular examples that are frequently revolving for the coordinate bond examples frequently you can see as per NCERT firstly which are given most common example is which one ozone very simple these are so frequently used example that you will don't even think about after learning them you can say okay that too I know I don't waste time in writing the identification of this bond or that bond I know that this is a dative bond present one is ozone in ozone central atom oxygen other two oxygen one double bond one dative bond any side double bond here also possible there also resonance is there okay resonance is there so I'm writing here this side now here this oxygen and this oxygen these two it is which bond between them dative bond we can show it by arrow means this is donor it is acceptor or it can be written in the form of charge also. It becomes minus, it becomes plus, and lone pairs you can mention as it is neutral oxygen, 2 lone pairs, negative oxygen, 3 lone pairs are there, and 3 bond with oxygen, this is a 1 lone pair. Yeah, Shreya. Bond length, yes, equal bond length because of resonance. Value, if you remember, it's good. Otherwise, bond length equal because of resonance concept. Other example in the module, you will get this type of that ammonia with BF3 or BCl3. Ammonia contains lone pair or not? Yes. BF3 has boron in which central atom boron has vacant orbital. Both will combine and this forms a coordinate bond between nitrogen and BF3 molecule. Okay? Getting it? Now here, what's the hybridization of nitrogen? What's the hybridization of BF3? I hope you are writing parallelly. Very good. I hope you are writing it is sp3, it is sp2. Okay? Now after the coordinate bond formation, both becomes which hybridized? So that question is given in the modules or in some exercise you will get such questions. So remember, it's a dative bond formed, one atom already sp3 but other becomes sp3 which is accepting it. Other example very important, just like ozone is CO. In CO molecule, the structure of CO is triple bond in which one is dative bond from oxygen towards carbon. That's why I'm saying solve or remember these frequently used examples in dative bond, and then whenever any question is there, apply that one. You will not get beyond that any example. Okay, getting it? Another example is which is given in the Lewis dot structure table in NCERT. It is NO3 minus. Already its structure we have completed in the BSCPR also and hybridization as well. But again, write it. The more you practice, the more fluent you will be in writing the structures. You become fluent in writing the structures, na? Getting it? Here it is dative bond. If you write normal bond, this O become minus, this nitrogen becomes plus. Or any side double bond, any side it is written because resonance is there. So in resonance, we can talk about such delocalization. Okay, getting it? These are those examples I am writing which are frequently you can say given in NCERT. Other example is which one? NO2 example is there, which is I think here it is not given in the structures because it is an odd electron molecule. And remember, it is having odd electron. Okay, NO2 structure. Here 1 point extra information. In case of NO2, hybridization of nitrogen is sp2, one thing. Second thing is bond angle is not 120. How much it is? 134. How? Because here not lone pair is there, here is odd electron is there. Due to that odd electron, what happened? The repulsion between odd electron and bond pair is less, rather which increases bond pair because of resonance. Here also double bond character, there also double bond character. So bond angle is 134. So NO2 if given anywhere in examples, so you can apply this concept that NO2 is more than NO2 minus as well as NO3 minus. That's why I'm writing here. Maybe somewhere it will be given, directly apply this or use this information. Okay, another example, very good example it is NH4 plus. Structure to normally we write it. You cannot differentiate, but it is N with plus charge. Getting it? These are frequently used questions for coordinate or dative bond. That's why if you write together, it will be easier to revise it. Bolo. In ammonium ion, what happens? Just think about it. Ammonium ion means it is formed how? Ammonia plus H plus. Ammonia has lone pair, H plus has vacant orbital. It means ammonia is donor atom, nitrogen, and H plus is acceptor. Therefore, in ammonia, 3 are normal hydrogen, normal C bonds, and 1 is a dative bond. One is a dative bond. So if the question is in ammonium chloride, how many types of bonds are there? So you will say that ammonium ion with chloride ion plus minus cation anion. That is which bond? Ionic bond between them. Very good. Yes, correct it is. Bhavyasri, correct. Durga Prasad, yes, very good. It is correct. Ionic bond. Then in ammonium ion, 3 are normal covalent bonds. And other one is dative bond or coordinate covalent bond. Getting it? So when you solve the module, that time it will be helpful. I hope that you have arranged the modules or not, all the students. Have you arranged the modules? Or you have given the request? Yes, very good. Do not think that okay, I have the material, I will do other material, I will do. If you have joined with full force that I will not leave anything. I will attend the class, I will solve the relevant material of the coaching so that in discussion also you will find it is relevant for you. Otherwise, lot of students, I am discussing some question, they are having no idea why. At home they have not purchased the module. So whenever you prepare with full force. If not arranged, talk to the NSR sir, talk to the groups where principal sir you talk, whoever is in your contact, but arrange the modules. Or whenever they are saying how to get the complete process done. Because I will only recommend what is better for you. In the revision time also what happens, we have given the grip assignment. Lot of students, they were not taking it. Lot of students, they have taken it from the campuses, and in that grip assignment so many questions came. In organic itself, I have observed almost 4-5 exact question given. Exact means structure wise it is given. Other concepts so almost there, but one thing is even structures you are getting. And these questions are framed from NCERT exercise questions framed, or exemplar it is framed, and these structures are also coming. So if you revise, keep on revising such things, it will be only relevant with the preparation. If you are selected, you will never feel like why I have bought it. So be practical, buy the material as early as possible. Everything you are well equipped with the material. Other example, H3O plus. Other example is H3O plus. Getting it? How? Water and H plus. Oxygen lone pair, what H plus vacant orbital, bond formed. Out of 3 hydrogens, 2 are normal bonds and 1 is dative bond. Any other example which you are thinking given in NCERT for dative bond? Yeah, it is already we have done. It is AB3L type structure, H3O plus. Okay, these are the most common examples. BF4 minus, you can say BF4 minus also. Lone pair has negative charge in H first. Lone pairs have positive charge. No, no, no. Actually, oxygen is neutral. It has donated the electrons. So oxygen gets plus. Hydrogen is not getting minus charge. Why? It is already plus H plus. It gained the electron and becomes neutral. Getting Shania? So oxygen is donating. It is neutral. If it is donor, it gets plus. Now, next part we can talk is, which is less important because already structures we know, but as per NCERT you will read still which part? Lewis dot structures. You will not skip anything, although Lewis dot structures are class 9, 10th level, which is cross and dot and everything is given, but you will try every question. Every example which is given, CO structure given, you will write that one. You will not leave it. Lewis dot structure, what is the concept? Lewis said atoms try to achieve the octet. So that is why these circles, cross and dots are framed. Like Cl2. In Cl2, both Cl. Valence electron 7. When they combine, so it can be shown like this, or it is shown in NCERT in this manner. When bond is formed, what will happen? This Cl has shared one electron, other Cl has shared other electron, and that is how 8 octet completed, its octet also completed. Between them, one bond is formed. Getting it? Okay, there is no dative bond, normal Cl-Cl. So with these examples type given, among them which I say good example, you can say ozone example already written. In dative we have written. So you will write that, and remember one thing, structures you already know. So no need to start from the scratch that I will write the bond, dot and cross. Nobody is taking care of that. Directly you can use the information which you already know by VSC-PR and hybridization. O3 we know by coordinate bond. Apply that one. Valence electrons all are involved. Like this way. Neutral oxygen, doubly bonded. Oxygen with 3 bond has 1 lone pair left. Oxygen with only 1 bond has 6 or 3 lone pairs. By formal charge, we can find the charges also. Or you can write dative bond also, both are correct. So here you can show either plus minus, or here our focus is not on the Lewis dot structures by valence electrons, because already we are pro with these structures, already know. But still, you have to read the NCERT cross and dot given for O3, NO3 minus, ozone structure, CO. In CO, that is the structure with dative bond, oxygen here, and here carbon. Yeah, correct it is. Correct, Shania, it is. Very good. CO structure written. Now, what is also given in the Lewis dot structures? This is giving also the formal charge concept. So we can apply both together. What is given? Formal charge. What's the meaning of formal charge? Formal charge is basically the charge acquired by the atom in a Lewis dot structure. Charge acquired by the atom in a Lewis dot structure. ठीक? So here formal charge formula is what? But you have to still read the theory given for formal charge, that more are the charges involved or more are the charges on the atoms in any Lewis dot structure, less will be the stability. You all know this part from resonance also, that more charges means less stability. Same here in Lewis dot structure, more are the charges, lesser will be the stability of that Lewis structure. Okay, what's the formula? We can use multiple ways, like formal charge is equal to number of valence electrons minus B plus U. What is V here? Number of valence electrons. on whatever atom we are taking because it is for atom, particular atom. Take bond, B is what? Number of bonds to that atom or with that atom. B is number of bonds with that atom, and U is number of unshared electrons left after bonding. Number of unshared electrons left after bonding. Written. So that is the way we can find the formal charge on the any atom by writing the Lewis structure. V, number of valence electrons on the atom for which we are finding the formal charge. B, number of bonds with that atom in the structure, and U is the number of unshared electrons left after bond formation or after bonding. For example, which is given there, ozone. I am also taking firstly ozone, so that the moment you read it, you find it. Yes, that is how it is decided. It is the Lewis dot structure of O3. It is the Lewis dot structure of O3. ठीक है? Now mark the oxygen. This is suppose oxygen A. It is oxygen B. It is oxygen C. Written up to this part, written or not? V minus B plus U, where V represent this one, B represent bonds with that atom, and U means unshared electrons left after bond formation on that atom. Now see, apply that formula. Formal charge on A. Formal charge on atom A. What will be the way? V minus B plus U. What is V here? Valence electrons, oxygen is there 6. Minus in bracket. How many bonds with atom A? Double bonds. You will mention 2 bonds. How many electrons left on atom A after bond formation? 4 electrons left. Answer is 0. So whichever method you know, apply that one. I am not saying apply this one. Whichever method you are getting it, apply that one, answer remains same. Similarly on oxygen B. Oxygen B में कितना? Valence electrons 6 minus how many bonds with oxygen B? 3 bonds. Okati, rundu, mudu bonds. And how many lone pairs, or sorry, how many unshared electrons? 2. So it is 6 minus 5 plus 1. Yes, correct it is. See, already देखो, already by coordinate bond you know this oxygen is plus, dative bond is formed, other is minus, already we know. We are just cross checking it by formal charge for practicing purpose. It will be 6 valence electrons, 1 bond with C atom plus 6 electrons left, 6 minus 7 minus 1. Getting it? This is the way you can find by any method, answer remains same. 1 oxygen 0, other central atom is plus 1, dative bond is formed, other is minus 1. That's why here you can show plus and here you can show minus. No problem, now getting it? Every one of you, you will not skip even Lewis dot structure concept from NCERT. Every example you will try, every table which is written there, NO3 minus O3, blah, 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 whatever, you will find for everyone. Other is solved example given. Which one? CO. Apply that for CO. This is the Lewis dot structure for CO. ठीक है? In C, this is the C atom. So Harsita, C atom, valence electrons, oxygen always same, 6. In the structure, it has formed only 1 bond. 1 bond. How many electrons left on the oxygen after bond formation? 6 bonds. Sorry, 6 electrons left. Why? Dative bond is formed, we know. So here 1 plus 6 minus 7 and then With 6 you are getting -1. Same way for CO, for carbon, and also find for oxygen. Already we know the answer. Remember one thing, we are just cross checking here. We are not putting any stress on the Lewis dot structure or this. Why? Because we know the structure of the molecule already. In carbon, valence electrons how many? 4. How many bonds with carbon? 3. How many electrons left on carbon? 2. Kitna hai? 4 minus 5 minus 1. Oxygen has to be +1. Why? Dative bond is formed. Carbon accepting, oxygen is donating. Oxygen valence electron 6. How many bonds with oxygen? 3. How many electrons left? Rundul electrons. Kitna aaya? +1. I hope you people are getting the pages where these terms are given. Bolo, till this point clear? Clear hai? So this part is already using the known information, directly writing the structure, and you can find out for these examples which are given here. You can find for you will read all this story, definition of bond length and everything, right? Then initially which is given here, yes, that you will read. These examples you will not skip. ठीक है ना? Lewis representation that is given, table 4.1. You will still read that table. Examples you will also practice. HNO3, NF3, O3, O2 given. Problem 4.1, CO molecule structure given this way. Already we have discussed it. NO2 minus you will practice separately. NO2 minus. Then you will try this. You will read that paragraph where stability term is given by using the formal charge formula. Though it's up to you, whichever formula you use. Then ozone molecule explanation is given, and here the theory of formal charge is given. Getting it? Up to this point clear? Up to this point we have done bond parameters, somewhat idea of dative bond with important part 6-7 frequent examples. And Lewis dot structure, few only you have to try as per NCERT. You will write everyone. You will not skip anything, but you will do it fast. You will not give much time to dot structure. Formal charge you can apply for whatever structure you are writing. ठीक है भाई, up to this point, anything you want to ask, because test syllabus में only resonance is left now. That concept, if you have a time, if you get the time, on Sunday I'll take the lecture for resonance. This one. This part is given, resonance here, here given. Okay? Done? ठीक है भाई, चलो फिर in the next class we'll meet. तब तक के लिए take good care of yourself. Prasad sir number, okay, I'll share again Prasad sir number, and keep on working at home. Do not waste time. ठीक है, डन, ओके। Yes, Kaushik, NO3 structure, NO3 minus already we have done. Quickly check it. This is the structure. You can write plus minus or dative bond. Lone pairs will be negative, means oxygen 3 lone pair, neutral oxygen 2 lone pair. आइपो इन दे। ठीक है भाई, चलो, ओके, बाय।